Alright. So, good day, everyone. Welcome to this subject on fundamentals of mixed signals and sensors. So, for this lesson, we'll be discussing differential amplifiers. So, itong mga differential amplifiers, this is an important topic before we go on to the operational operational amplifiers. Kung saan mas matagal yung ano natin, yung discussion natin. But before we go on to that discussion, dito muna tayo sa differential amplifiers because differential amplifiers play an important role dun sa operation ng mga operational amplifiers. So, kumbaga sa system, subsystem siya na isang operational amplifiers. So, simulan na natin. So, bago matapos tong discussion natin, we'll be able to describe ano ba yung mga differential amplifiers. And then, paano nag-operate yung mga differential amplifiers. Also, we'll be able to discuss yung basic operation ng mga differential amplifiers, yung mga modes of signal operation. Meron tayong tinatawag na single-ended differential input, and then double-ended differential input. And then, meron din tayong tinatawag na common mode operation. And then, lastly, we'll be able to define and determine yung tinatawag nating common mode rejection ratio sa mga differential amplifiers. Okay? So, let's start. Yan. What is a differential amplifier? So, a differential amplifier is a BJT or JFET amplifier that produces outputs that are a function of the difference between two input voltages. So, meron daw tayong dalawang inputs, and then yung output ng differential amplifier natin is the difference ng dalawang input na yon, pero ina-amplify natin. So, hindi na siya kaparehas nung input signal natin. Okay? So, amplified pero yung ina-amplify natin yung difference ng dalawang input voltages. Right? So, the differential amplifier has two basic modes of operation. Differential, differential input operation. Kumbaga, yung input natin dito is magkaiba. So, ang nagiging operation natin is subtraction. And then, meron din tayong tinatawag na common mode operation. Ito naman, yung input natin are the same. No? So, meron tayong circuit dito which is the basic configuration ng mga differential amplifier, right? So in this case, meron tayong dalawang transistor, Q1, Q2, and then we also have dalawang input signal, right? Then meron tayong RE, then negative voltage, positive supply voltage, and then dalawang resistor. So, in this case, ang configuration natin is that parang meron tayong common emitter circuit in this form na ikinabit natin sa common base na circuit. So, ganun ang itsura ng isang differential amplifier. So, para bang nangyayari dyan? First, yung dalawang input natin, let's say, sample lang, nilagay natin ng 0 lang yan, or ground natin, no? So, meron tayong unang loop dito. I-analyze lang natin, ano? Yan. So, kung mapapansin natin dahil sa symmetry, yung current sa emitter side ng dalawa, no? That is I emitter's first transistor equal yun sa current dun sa second transistor. Okay? Since yung emitter currents na yan combine dito sa RE, okay? So, equal din yan sa 1/2, no? 1/2 ng current na dumadaan sa resistor R sub E, no? Sabihin, itong current na to ay E sub 1, ay E sub 2. Yes, equal sila, pero paghahatian nila yung current na dumadaan dito sa I, R sub E. Kung saan, yung ating I R sub E equal yan sa VE. So, naalala ninyo na yung ano natin ha, yung DC analysis. VE minus VEE all over R sub E. Yan yung loop natin, no? Yan. VE minus VEE minus all over RE. So, we are going to approximate that yung ating I sub C sub 1 is approximately equal yan sa I sub C sub 2. And dahil equal naman ang IC sa I sub E, we can say that the I sub C sub 1 is approximately equal to I sub C sub 2, and it is also equal dun sa current natin sa R sub E, no? Divided by 2. So, yung ating I sub C din dito, na dumadaan dyan, equal din yan dito. So, ang nagde-determine sa atin ng ating current is yung resistor dito sa R sub E, no? Since yung parehas na collector currents and collector resistors are equal, so mag-equal talaga yan, no? And we also note that yung ating B sub E equal yan sa B sub B minus 0.7 volts. Alright? So, yan. Yan yung ating mga common na mga DC voltages analysis doon sa ating differential amplifiers. Okay? So, anyway, ang pinaka-importante dyan is maintindihan natin yung operation ng isang differential amplifier. Okay? So, we have um, three common modes of signal operation ng isang differential amplifier. Okay? So, ano ba yung mga yon? So, una, we have the single-ended input. Yan. So, ano bang nangyayari dito sa single-ended input na to? So, sa single-ended input, it's either yung sa 1, yung meron tayong input or sa 2, no? So, in this example, meron tayong input sa 1 and then yung ating 2, siya yung naka-ground or wala tayong input dyan. Okay? So, once na nagkakaroon tayo ng input dito, yan, nagkakaroon ng imbalance dun sa ating current sa second part or sa Q sub 2. So, let's say, tumataas yung ating current dito, yung ating voltage tumataas dito. Yan. Yung ating namang output sa 1 dito is, since common collector yan, out of phase dun sa ating input. So, habang tumataas yung voltage ng input natin, yung output naman sa 1 is baliktad, bumababa naman siya. No? Bakit? Kasi dahil tumataas yung voltage dito, bumababa yung current dito. No? And dito naman, sa output sub 2, dahil habang tumataas yung voltage natin dito, sa input, bumababa yung current naman dito sa side na to. Dito naman sa side na to, siya yung kumukuha ng current. So, tumataas yung current dyan. Since zero lang yung ating input dito, siya yung nagiging in phase dun sa ating input. Kaya yung output natin sa 2 will be in phase dun sa ating input sa 1 and amplified. Alright? So, ganoon lang yung operation ng mga differential amplifier in a single input. So, pag nababaliktad yung signal, ang tawag natin doon na, ang term na ginagamit natin is inverted. Lalong ginagamit natin to sa inverted. Yung term na to, gagamitin natin yan sa op-amp, no? So, yung input natin sa 1, inverted. Pero sa 2 naman, non-inverted na siya. Same siya nung ating input. Okay? So, ang nagiging cause niyan is that sa una kasi, ang circuit natin is sa 1, common emitter siya. And then, sa pangalawa naman, nagfa-function tayo as common base, kaya nagiging ah, non-inverted yung ating output dito. Alright? So, next na tayo. Dito naman tayo sa double-ended differential input. Yan. So, in this configuration, meron tayong dalawang opposite polarity or out of phase. Ayan, pansinin natin yung signal natin dito. Ito yung una. Ito yung pangalawa, out of phase sila. No? So, ina-apply natin yan sa input ng ating differential amplifier. So, hindi ko na pinakita yung mga ano ha, yung mga transistor. Pero ito yung symbol natin para sa differential amplifier. Okay? So, each input affects yung ating outputs. So, paano nangyayari yan? Yan. So, sa una kasi, let's say yung V sub 1, katulad pa rin ng single-ended, yung output sa 1 is a inverted. Tama, di ba? Yan. Let's say ito yung output nung sa 1 lang. 1. Sa 1 pa lang yan. Then, pag inad natin yung sa 2, dahil nasa 2 siya, pag output sa 1, non-inverted, di ba? So, parang yung output naman ng 2 is magiging ganito rin. So, pag inad natin yung dalawa na yan, so, ito na yung kanilang output. So, ganun ang operation naman sa double-ended differential inputs na ang input natin is parehas out of phase. So, kung ano yung nagna-non-inverting siya dun sa kamatch niya or ini-invert niya yung signal dun sa kamatch niya na number. For example, yung ating V sub 1, ganito yung ating input. We are expecting na dun sa output sa 1 is an inverted pero amplified. Right? So, ganun yun. Ha? Then, for the last part, yung ating common mode inputs. So, ganyan. Ito yung isa sa mga pinaka-importanteng aspects ng operation ng differential amplifiers na dapat nating matutunan. We are considering here the common mode condition where yung dalawang signal na pinapasok natin, so yan, ito yung una, ito yung pangalawa, yung pumapasok are in phase. They have the same phases, frequency and amplitude. So parehas na parehas ng pinapasok natin. So again, pag inanalyze natin to, considering each input signal acting alone on the differential amplifier, so mangyari dun sa una is syempre out of phase, di ba? Out of phase yung una. Then yung pangalawa, yan, gagayahin yan. Non-inverting. Yan. So, mangyari, nagiging zero, nagka-cancel out sila parehas. Nagka-cancel sila parehas dun sa each output signal. Ano ang nangyayari dito? We are noticing that the corresponding signals sa output 1 are of the opposite polarity. Parehas din dun sa number 2. So when input signals are applied to both the inputs, the outputs are superimposed and they will eventually cancel, resulting to a zero output voltage katulad ng pinapakita natin dito sa figure. Nagsi-zero na siya kasi nagka-cancel yung dalawang output signals, no? So ang tawag natin dito sa action na to is common mode rejection. Okay? Again, we call this action common mode rejection. Yung importance ng situation na to is magagamit natin kasi sa mga unwanted signals. Let's say, meron tayong input. Tapos ginamitan natin na common mode rejection. So, mangyari dyan, nagka-cancel yung ating mga unwanted signal. Kasi, dadaan siya sa common mode, hindi siya makikita dun sa output. Okay? Pero, ang ano lang dito is, hindi madi-distort yung ating desired signal. So, yun yung kagandahan sa paggamit ng ganitong circuit. Common mode signals, yung noise natin, usually kasi ano yan, result yan ng mga pick up of radiated energy on the input lines. So, kumbaga, sa input, meron tayong mga radiated energy dyan or yung mga katabi nating power line, mga 60 hertz power line and some other sources. May nakukuha tayong energy dyan na pwede nating ma-amplify. Kaya tayo gumagamit ng common mode input is that para maiwasan natin na makuha yon. Kasi ang mangyayari dun sa mga unwanted signals is magka-cancel out lang sila dun sa ating output. So, yun yung importance ng common mode rejection. Okay? So next, we're going to discuss common mode rejection ratio. Ano ba yung common mode rejection ratio na yan? Okay? So, to before I discuss kung para saan yan or ano, let me define common mode rejection ratio. The measure of the amplifier's ability to reject common mode signals is a parameter called common mode rejection ratio or yung CMRR. So, desired signals appear on only one input or with opposite polarities on the both input lines. So, itong mga desired signals na to, na-amplify natin and lumalabas naman yan sa output. Although, yung mga noise or unwanted signals appearing on the same polarity nung parehas nating input are essentially canceled. Kasi nga common mode yung ginagamit nating operation. So yung measure ng ability ng isang amplifier to reject yung mga common mode signals or yung noise, tawag natin doon CMRR, no? Ideally, so gusto natin na yung differential amplifiers natin, they would provide a very high gain for desired signals. And zero gain para dun sa mga common mode. So, hindi natin dapat ma-pick up yon. However, yung mga practical differential amplifiers, they do not exhibit yung mga ganong conditions. Although they do exhibit a very small common mode gain, meron pa rin. Although usually much less than 1. Pero meron. While providing a high differential voltage gain dun sa ating mga desired signal. So, habang tumataas yung ating differential gain with respect to the common mode gain, mas maganda, di ba? Dahil mas na-amplify natin or mas nakukuha natin yung mga desired signal versus dun sa mga unwanted signals. So, yung ratio na yon, yung ratio ng differential voltage gain and yung common mode gain sa ating amplifier, yun yung ating CMRR. So, habang tumataas yung ating CMRR, mas maganda. So, etong ratio na to, this suggests that a good measure of differential amplifier's performance in rejecting unwanted signals is the ratio ng kanyang voltage gain and kanyang uh, common mode gain. Yan. So, CMRR daw is equal to the differential voltage gain divided by the common mode gain. So, gusto natin mataas yung ating differential voltage gain and then mababa yung ating common mode gain. Ideally, dapat nga 0 yan. Pero, wala kasing ganyan, no? So, meron tayong from 0 to 1. So, yung ating mathematical symbol for differential voltage gain is A sub V of D. And yung common gain naman, common mode gain is A sub C sub CM. Okay? So, yung ratio niyan dalawa na yan is yung ating CMRR. So, the higher the CMRR, mas maganda. A very high value of CMRR, ibig sabihin yan, mataas yung ating differential gain, mababa yung ating common mode gain. So, yung CMRR, it is often expressed in decibels. So, itong first formula natin, ratio lang yan. So, kailangan kunin pa natin yung 20 logarithm of this value para ma-express natin yung CMRR in decibels. Alright? So, pakitandaan yung formula na yan because we are going to use that in the next example. Sample problem. So, a certain differential amplifier has a differential voltage gain of 2000 and a common mode gain of zero point 0.2. Determine the CMRR and express it in decibels. So, medyo madali ito, no? Kasi given na sa atin yung ating differential voltage gain and yung common mode gain sa problem. All we have to do is to use our formula ng CMRR and then express it in decibels. Alright? So, let's try to solve this problem. So, yung given sa atin is that we have a voltage gain A sub V of D equal to 2000, and we also have the common mode gain of zero point 0.2. So, yan. Then yung ating required sa atin kunin yung ating CMRR, and then kailangan din yung CMRR in decibel. Ayan. So, ang solution natin diyan, formula natin ng CMRR is CMRR is equal to yung ratio ng ating differential voltage gain and yung ating common mode gain, di ba? So, it is now equal to 2,000 divided by zero point 0.2. Therefore, yung ating CMRR is equal to 10,000. Ayan. If we are going to express it in decibels, no? Yung ating CMRR is equal to 20 logarithm of 10,000, which is equal to 80 decibels. Alright, so yan. You now have the answer for this question. Medyo madali pa siya, di ba? So, ano ibig sabihin yan? A CMRR of 10,000, ibig sabihin yan, pag meron tayong input signal, yung ating desired input signal will be amplified 10,000 times more than yung ating unwanted noise, di ba? So, ganun kalayo yung difference. For example, if the amplitude of the differential and the differential input signal and the common mode noise are equal, say pares silang uh, 1, no? So yung desired signal will appear at the output 10,000 times larger or greater in amplitude than the noise. So nasusuppress natin yung noise. So ang effect nito, yung noise or yung interference uh, will be essentially eliminated. So yun yung importance ng CMRR sa circuits. Okay? Next. Yan. Another problem, a differential amplifier shown here has a differential voltage gain of 2,500 and a CMRR of 30,000. Ito medyo mataas. So in part A, itong figure na yan, a single-ended input signal of 250 microvolts RMS is applied. At the same time, a 1 volt 60 hertz common mode interference signal appears on both inputs as a result of radiated pickup from the AC power system. While in part B, a differential input signals of 500 microvolts RMS each applied to the inputs. Okay? The common mode interference is same in part A. So, yan. So, sa part A, meron daw tayong input signal. Yan. Pero single-ended. No? Ibig sabihin, yung isa lang yung merong input. Then, meron tayong parehas na noise dyan or unwanted signal sa dalawang inputs natin. So, sa 1, ang pumapasok pala dyan is yung ating desired signal plus yung ating common mode or yung interference. Sa second input, ang pumapasok sa atin dyan, yung noise lang. Okay? Um, sa part B naman, we have a differential input signals. Parehas meron sa dalawang input. Although they are out of phase base dito sa figure. And then, parehas na input, meron niyang uh, dito, common mode or yung ating interference. Okay? So first, ang problem natin is to determine yung ating common mode gain. Ano ba yung ating common mode gain? Or yung pinapahanap sa atin yung C common mode gain. No? So first pala, ang pinapahanap is A sub C M question mark. And then, pinapahanap sa atin yung CMRR in decibel. Then third, pinapahanap sa atin yung RMS output signal for part A and B. So, voltage out for part A and part B. Then, pinapahanap din sa atin yung determine the interference voltage on the output. No, RMS voltage, RMS ng output in both A and B. So, paano natin, ang daming tanong, ano? Subukan natin sagutin yan. Alright? Para masagot natin yan, ang alam kasi natin is that meron tayong CMRR and meron tayong uh, voltage or differential voltage gain. So, in this case, mahahanap talaga makukuha natin yung common mode gain. No? So, let's say yung part A, ang alam lang natin is that yung CMRR equal yan sa ratio, di ba? Ratio ng ating voltage gain divided by the common mode. Yan. Therefore, it is also true na yung ating common mode equal din yan sa CMRR or rather the voltage gain is sub B divided by the CMRR. Okay? Diba ganyan? So, para makuha natin yan, yung ating differential voltage gain, sabi meron daw tayong 2,500 divided by 30,000 ng ating CMRR. Therefore, yung ating gain is now equal to 0.083. Di ba? Nasagutan na natin. Then, we are also going to express yung ating CMRR in terms of decibel. So, ito medyo madali lang to kasi kukunin lang natin yung 20 logarithm, di ba? 20 logarithm, 20 log of 30,000, it is equal to 89.5 decibels. Right? So, third, we are to find yung output, ba? Pinapahanap sa atin yung output. Paano natin kukunin yon? So, yung alam lang natin, the differential input voltage is the difference between the output voltage on input 1 and that on input 2. No? Since sa part A, yung output or yung input 2 natin is grounded, its voltage is 0. Therefore, yung ating output, V sub out is equal to V in 1 minus V in 2. Di ba? So, since ang ating 1 is ilan? Tama ba? 500. 500 or 250. No? 250 yung ating input, 250 microvolts minus 0. Therefore, yung ating output is 250 microvolts. Yan. So, sa part B naman, so ito yung sa una, no? Sa part B, voltage out is equal to, ilan yung input natin? 500, no? 500 microvolts minus, dito naman, ang gagamitin natin is negative 500. Bakit? Kasi kung mapapansin natin, yung ating signal is inverted or out of phase. Therefore, dapat negative. So, ang sagot natin is that magiging 1,000 microvolt. Or equal yan sa, ilan yan? 1 millivolt. So, ayan. Saan yan yung ating papasok sa, yun yung papasok sa amplifier. Okay? Yan pa lang yung papasok sa amplifier. So, yung ating voltage out sa 1, no, dito, gamitin natin ng blue. Yung ating voltage out 1, kailangan i-multiply natin yung ating dito yan, no, voltage out ng 1. I-multiply natin itong V sub out times yung ating CMRR. Therefore, 250 microvolt times CMR natin is 30,000. I mean, hindi CMR. Yung ating voltage gain kasi ito yung ating desired signal. So, 2,500. Yan. So, ang ating voltage output sa 1 is equal to 1 point calcio 250 times 25 0.625 volts. volts na siya kasi microvolt tapos times 2,500. So, mawawala na yung micro dyan. Okay? 0.625 volts RMS. Yan. Dito naman sa pangalawa, V sub out 1. So, ito naman yan. Equal yan sa 1,000, no? 1,000 microvolt times yung ating voltage gain. Yung ating voltage gain is equal sa same lang, no? 2,500. It is equal to 2.5 volts. 2.5 volts RMS. So, ayan. Yun yung ating sagot sa number 3. So, now we are to find out ano naman yung ating common mode. No? Output naman ng common mode dun sa ating output. So, paano ba yan kinukuha? Siguro, burahin ko na lang muna tong iba, no? So, pakitandaan yung sagot, ha? Yan. So, ang alam lang natin na ang pumasok is 1 volt. No? Pero kanina, nakuha nating common mode ay ilan? Ang nakuha nating common mode is 0.083. Tama ba? The common mode gain, in simplest terms, is equal to the voltage output divided by the voltage input ng ating mga common mode signals. Right? So, if we have 0.083 as our common mode gain and hinahanap natin yung voltage output, right, ng ating common mode, and we have a signal of input of 1 volt. Okay? Therefore, yung ating output voltage ng ating common mode signal is equal to 0.083 volts or actually 83 millivolt. So, lumiit pa siya, no? So, lumalabas dito na lumiit pa yung ating na atin weight pa natin yung ating interference, no? Talagang kung maganda lang yung ating differential amplifier is liliit pa yung ating interference. No? Although sa mga practical differential amplifiers kasi hindi natin yan ma-eliminate. So dahil hindi naman ideally hindi naman or practically hindi zero yung ating common mode gain. All right? So I think that's it. Let's check. So ayan, that's it. That's for this lesson on differential amplifiers. We have defined ano mga differential amplifiers. We have discussed yung mga common mode operations ng differential amplifiers. And then we discussed or define and discussed ano ba yung common mode rejection and kung ano yung common mode rejection ratio. Ano yung importance ng CMRR. And nag-analyze tayo ng mga circuits to further illustrate ano yung gamit ng CMRR sa circuits sa mga differential amplifiers. Okay? So if you have questions, just comment down or i-message nyo lang ako para masagot ko regarding dito sa differential amplifiers. Okay? So I hope meron kayo natutunan and maraming salamat sa pakikinig. See you on the next lesson. Okay, maraming salamat. Bye-bye.